Hello, Luke. Welcome to lesson 51. So today we're going to be talking about graphs of linear equations, all right, which means that we'll be kind of building off of what we learned in the last lesson, in lesson 50, in regard to graphing ordered pairs and equations of two variables of the first degree. So let's start by just a quick review and show you an equation similar to what we've talked about in lesson 50. So if I have y is equal to x minus 1, what kind of equation is this? Well, if we look at it, we see that it is an equation in two variables. So it's in two variables, right? There are two separate variables, a y and an x here. We can also say that it is a first degree equation, right? And how do we know that? Recall that to determine the degree of an equation, we look at the highest degreed term in the equation. So in this case, the variable terms, x and y, they're both of degree 1. So they kind of tie as the highest degree, and that degree is a 1. So it's considered a first degree equation in two variables. All right? And these are the kinds of equations that we are going to be focusing in on in this lesson and in some upcoming lessons as well. So another way to describe this kind of an equation is a linear equation. All right, and we're going to talk a little bit more about this, and then you'll see why we call it a linear equation. All right, but just to be clear, right now we're only dealing with equations that are in two variables and are in the first degree. So, recalling back to lesson 50, we remember that for an equation of this type, there are sets of solutions instead of just single solutions. And the reason is we need a value for x and we need a value for y. We have two unknowns here, so it makes sense that we need kind of a double answer. We need an answer for the x and an answer for the y. And recall that we decided the best way to write that was in the form of an ordered pair. So we have a set of parentheses, and inside the set of parentheses, we put the solution for the x variable followed by the solution for the y variable. So we have the xy ordered pair. Okay. Now, we also talked yesterday about, or in lesson 50, about how we have infinite ordered pairs that will satisfy this equation. So, for example, if we decide that we'll choose a 1 to be the value of the x, what would the y value be? Well, if we plug in the 1 for the x, we end up with 1 minus 1, which is 0. So the y equals 0. So 0 would be the value for the y, and we end up with an ordered pair of 1, 0. So when x is 1, y is 0. Okay, so that is a solution to this problem. But we could have other solutions as well. What if we chose to have x be a 2, for example? If we have x be equal to a 2, well, then the equation becomes y equals 2 minus 1, which is 1. So therefore, y is going to be equal to a 1. So another solution to this problem would be 2, 1. All right, and we could keep doing this forever. We could just keep plugging in new values for x, and those new values will produce new values for y, and that would be the ordered pair, and we would just keep going on and on and on and on. So if on a test, for example, if I were to tell you, okay, I want you to find all the solutions to this equation, this first degree two variable equation, and that would be impossible for you. You would be taking the test forever because you could continue listing more and more and more solutions. All right, so that would not be a very nice thing to put on a test. However, we have found a way in mathematics to show all of the solutions for this equation without having to write forever and ever and ever. All right? And how do we do that? Well, this ties back to what we learned in lesson 50. We're going to be talking about graphs. So let's show the solutions for this equation on a graph. And we'll see that not only will we be able to do this, but it'll also be a way of showing all the solutions for this particular equation. All right, so how do we do it? Well, to set it up, we start by just building ourselves a chart. Okay, we're going to build ourselves a chart here. And in this chart, we're going to select values for x as inputs, and then that'll produce y values as outputs. Okay, so this first row here is going to be our x row. The second row is going to be our y row. And all we're doing is just finding some solutions to this equation. We're not going to find all of them, obviously, but we're going to select some. And in this case, I've got 5 boxes on the top and the bottom row. So we'll select 5 solutions for this equation. And we can select any 5 we want. But in general, it's nice to kind of keep these solutions small. So we select kind of easy numbers, small numbers that make solving the equation easy. All right, so we already solved it twice. We solved it once here, and we solved it again here. So let's use those as 2 of our ordered sets for this graph or this chart. So the x was a 1, and when the x was a 1, the y was a 0. Okay, that's one ordered pair. The second ordered pair, the second column here, will have 2 for the x, which produced 1 for the y. And then we need to figure out 3 more. So let's select 3 other values for x. We haven't selected any negatives, so let's throw a couple negatives in there. Let's throw in a -1. So if we have a -1 for an x, what does that give us for the y? Well, if -1 is x, we're going to end up with y equals -1 minus 1, which is going to be -2. So y is a -2. And let's choose a -2 for x. And if y is a -2, we have a -2 minus 1, which is a -3. I'm sorry, did I say y? X is a -2. Y is going to be the -3. And then finally, let's choose one more. And we'll pick what generally is the easiest one to select of them all. And that is, what about x being 0? So if we set x equal to 0, what does that do for y? So y then is going to equal 0 minus 1, which is going to be a -1. All right, so now we have kind of a chart here, and we chose to select 5 values here. You're going to see that the bare minimum would require 2 in this case, but it is good to do a couple more, and 5 is a nice number. So we'll do 5 in this case. And the next step is we're going to actually plot these points on our graph. Because these ordered pairs are composed of an x element and a y element, we can graph them on our graph with the x element corresponding to the x-axis and the y element corresponding to the y-axis. So we have x is equal to 1 and y is equal to 0. So here would be 1. That's where x equals 1 lives on our graph. But then y has to be equal to 0, which in this case, y equals 0 is right in the center, right in the origin of the graph. So the point 1, 0 is going to be right here at x equals 1, y is equal to 0. All right, then our next one is x is equal to 2, y is equal to 1. So at 2, 1, that would put us right here. Excuse me. And then finally we have, or not finally, but the next one we have -1 and -2. Well, x equals -1 is here. -2 is going to be here. So my negative is kind of far out there. I don't like that. Let's put that a little bit more exact. Put it right here. That's where -1, -2 is equal to. And then let's go on. We have a -2, -3. So we have a -2. -3 is going to put us right here. And then we have a 0 and a -1. So where is x 0? Again, it's going to be right at the origin, right in the center where they cross over. So that's x equals 0. Y is equal to -1. That moves us down to this point here. And that's where we'll put our 5th point. And if we look at this graph, you may notice that our dots are actually starting, if we were to connect them, they're starting to kind of take the shape of a line, right? They're all kind of in this slanted line position here. And what's interesting with these first degree equations in two variables is that they always form a line. Not just this one, but all of them form lines. Isn't that interesting? And if we were to keep selecting other variables for x, all of the xy coordinates, the solutions to this equation, they're all going to fall on that line. Okay? So we chose whole numbers, but we could have chosen, fractions as well. If we would have chose x is equal to 1/2, well then y would be equal to 1/2 minus 1, which is negative 1/2. So if x was 1/2, which is somewhere right around here, y is negative 1/2, which puts us somewhere around here. And lo and behold, that's right on our line, right? Right on our line. And in fact, no matter what solutions we chose to compute for this equation, the solutions are always going to be directly on this line. And I can extend this line just straight out. Just kind of draw some more dots here, right? And I can extend it straight out down this way. Just more dots, all right? And all of the solutions are going to fall on that line. So what we can do is then draw a line extending from here all the way up to here. And it's passing through all of these points, all right? And it's going on for infinity in both directions. So we'll just throw an arrow on the end of this line. So for infinity in both directions, this line is continuing to extend, and anywhere on that line is a solution, is a location for a solution to the equation y equals x minus 1. All right? So by drawing this picture, I've actually shown an infinite number of answers to this problem, because you can take, and I'll just do this maybe in a different color, but you can take any point you want. If I just jump on this line, I jump right here. All right? Well, that looks like it's around 4.5. And it looks like, or I should say negative 4.5 on the y-axis, and it looks like it's at around negative 3.5 for the x. So negative 3.5, if I write the x first, negative 3.5, negative 4.5 appears to be a solution because it's on the line. Now I was guessing at that location, but if I could be very precise on where that location is, that would be a solution to this equation. All right, and I could select any point I wanted. I could maybe jump here, or maybe I could jump way up here. Any spot on this line is fair game for finding a solution to this equation. In fact, the only solutions to this equation are going to be living on this line. So this is a way of showing all the solutions to this equation without having to write them down for infinity. Now you have to admit, that is pretty cool. All right? That is pretty cool. So, and again, these lines extend off in infinity in both directions. So there might be, I could maybe select dots up here too. I could just keep going for infinity in both directions as long as I'm on that line. So that is how we express the solution to an equation of two variables of the first degree. Okay? Excellent. Let's try a couple more. All right, so here I have just an empty graph, but let's select an equation. Let's choose the equation to be y is equal to 2x plus 1/2. Yeah, we'll leave the fraction out for right now. Let's just go 2x plus, well, we'll go minus actually, minus 1. Okay? So before we had x minus 1, now we've got 2x minus 1, so they're very similar. But let's go ahead and solve this and graph the solution. So the first step again is to make our chart so that we can just pick a couple of points and start building that line on our graph. Because this is an equation of the first degree in two variables, we know that whatever this graph is going to look like in the end, it's going to be a line. It may be slanted in this direction, it may be slanted in this direction, it may be kind of flat or uphill, downhill, whatever it might be, but it's going to be a straight line. There aren't going to be any curves to it. And you're going to have to just kind of take that on faith right now because that's what I'm telling you. But whenever we have an equation of the first degree of two variables, we are going to end up with a straight line, okay? No matter what numbers you choose to put in with that. All right, so let's select a few points here, a few solutions. So we have our x solutions, our y solutions, and last time we selected 5. Maybe this time we'll just do, maybe 4. Okay, because technically, if it's going to form a line, technically all you need is 2 points. That's all you need to form a line. If I have a point here and if I have a point here, well, then I know my line is going to be, well, it's not right on the dots, but that's going to be, a line that looks like this. All I need is 2 points to be able to draw a line. However, it is good to at least do 3 or 4. It just makes our line just a little bit more accurate. So if we do 4 in this case, what would you like to choose for x? Well, I always like to choose the 0 because that's usually a very easy one to plug into the equation. So 2 times 0 is 0, minus 1 is just a minus 1 for y, right? Then I like to use a small positive number. Maybe we'll do a 1 in this case. 2 times 1 is 2. 2 minus 1 is 1 for the y. But I do like to look at the negative side of things too. So let's look at a negative 1. And 2 times a negative 1 is a negative 2. And a negative 2 and a negative 1 is going to be a negative 3. And then if I choose to use maybe we'll go a little bigger in this case. Let's maybe go with, let's go at 2, I guess. I guess we're not going too big, but we'll do a 2. So 2 times 2 is 4, minus 1, y is going to be a 3. So there we have our 4 points. Let's plot those on our graph and see what that looks like. So we have a 0 for the x, negative 1 for the y. That puts us right here. Okay, then we have a 1 for the x and a 1 for the y. Well, here's the 1 for the x, here's the 1 for the y. That puts us right here. And then we have a negative 1 and a negative 3. So a negative 1 is here, negative 3 moves us down to here. Okay, now you can already see this line is taking shape. We could draw the line even now. But just to make it a little bit easier for us, we'll put in that 4th point, 2 and 3. So x is 2, y is 3, that's way up here. And that should give us a pretty good positioning for our line. So our line is going to look something like, and this isn't going to be perfect, but it looks something like that, right? Kind of passing through those 4 points. Okay, so that is the solution. Maybe, I don't know, twist this a little bit. Maybe that's a little bit better. So that would then represent the solution to our problem, going for infinity in both directions. Anywhere on this line lives a solution for this equation. Okay? Excellent. All right, let's try another one. Let's do a fraction one. Let's do, maybe we'll use the same graph, but we'll go in a different color. Let's go y is equal to 1/2 x plus 1. That's kind of a good one. Let's go with that. Well, you know what? Let's do a negative 1/2 x. Let's just make it a little bit different. So we got a negative 1/2 x plus 1. So let's plot this on our graph. And again, to do that, we're going to start by writing our chart with our x's and our y's. So we have our x's, we have our y's, and I don't know, how many do you want to do? Let's maybe just do however many I can get in here, maybe 4. Okay, so what should we choose for x? Again, I always like 0. 0 times 1/2, well, that's 0. And then plus 1, well, that's going to be 1. So that just makes things easy to start with that 0. And then let's figure out what we'd like to use. Now, we could use a 1, for x, because that's kind of a smaller number, and generally that's an easy one to plug in. But I'm going to try to use my head here a little bit and recognize that I have this fraction, and I don't really like dealing with fractions. So instead of using a 1, because when I multiply that out, I'm still going to have a fraction, let's use a 2 for x. because if I use a 2, when I multiply that by 1/2, I'm going to get a whole number. So 2 times 1/2 is just 1. And since it's a negative 1/2, it's a negative 1. So I have a negative 1 plus 1. Well, that's 0. So that worked out nicely. Now, what's another value for x that I could get that I wouldn't have to deal with fractions? Well, I could do the opposite. I could do a negative 2. And a negative 2 times a negative 1/2 is going to be a positive 1. And a positive 1 plus 1 is going to give me a 2 for the y, right? And then my last one here, again, I could try to do maybe a 3 or something like that. But again, I'm going to try to get rid of this fraction. So I'm going to choose to use a 4 because I know that 4 times a negative 1/2 is going to be a whole number. So 4 times a negative 1/2 is going to be a negative 2, right? 4 divided by 2 is a 2. It's a negative 2. And a negative 2 plus 1 is going to be a negative 1. So again, I've avoided getting fractions for my answers. Makes it easier trying to chart that on my graph here. All right, so now let's say we plug these in. X is equal to 0. Y is equal to 1. That's going to put us right here. Okay, and when x is 2, right over here, y is 0. So we're right on the x-axis there. Y is 0. X is 2. And then we have a negative 2 for x and a positive 2. That's going to put me right here. We can already see our line forming. And then we have a 4 and a negative 1. So we have a 4 over here, followed by a negative 1 for the y. That's going to put us right here, right? So we can then roughly, oh dear, that's not what I want. Roughly draw our line here. And I'm going to maybe try to move this so it fits a little bit more the way I want it to. Something like that, right? So that is the graph of our solution for this equation. So this one was just kind of going in the opposite direction as our first one. Okay, and later on we'll learn some clues that will indicate to us what the picture of the graph is going to look like even before we do these charts. I've already given you one, and that is when it's an equation like this in 2 variables and it's of the first degree, it's going to be a straight line. So that's one clue. But there are other clues as well, and later on we'll be more specific. But maybe one I'll just point out is if there's a negative here on the front of the x value, it's always going to be going downhill. So if you think of this as, going from left to right, you're kind of going downhill. Whenever you have this negative before the x term, you're always going to be going downhill. If you have a positive before the x term, you're going to be going uphill like we did here. So those are just some mental things to know so that you can kind of get a feel for what that graph is going to look like even before you plug things in. And then you can always check it after you're done and make sure it kind of matches what your expectations are. All right. But anyway, let's try another one. What if we have, we'll go a different color. What if we have y is equal to 2? What about that? First of all, you might say, well, whoa. That's not what we're talking about. It's not an equation in 2 variables. And I might say, well, you might be right, but what if I were to tell you that there's an invisible x here and it's raised to the 0 power, right? Wouldn't that be equivalent to y equals 2? Because x to the 0 is just 1, and 2 times 1 is 2. So that would be equivalent to just y is equal to 2, right? So I could kind of force this into an equation of 2 variables if I wanted to. And it would still be of the first degree because y is the one with the highest degree, and that's a 1, so it's in the first degree still. All right, so we could force this into being an equation of 2 terms or 2 variables in the first degree. All right, so that means we could definitely graph it. So y equals 2. Well, what would that look like? Well, you might say, well, gosh, if I draw my chart, how is this going to work? I don't even have an x term up here. So what would I do for my x's and my y's? Right? And actually, it's very simple. You can choose anything you want for x. I could make this 100. Okay? And again, imagining behind this scribble, we have that x to the 0. Well, 100 to the 0 is just a 1. It doesn't matter what the x is. It's going to be raised to the 0, which is going to equate to just a 1. So no matter what, this is going to be a 1. It doesn't matter what we plug in for x. It's going to be a 1 times this 2. So the y is always going to be 2. If I plug in a negative 100, no problem. A negative 100 raised to the 0 is 1. It's not a negative 1, it's a 1. And a 1 times 2, well, that's going to be 2. Okay? So it's still 2. So no matter what I plug in, we're going to, and I could, keep plugging numbers in, but that's kind of pointless. If you plug something in, you're going to get 2. If I plug in a negative, 1,000, I'm going to get 2. All right? I'm always going to be getting 2 for no matter what I plug in for x, because either you can think of it as being there's an x to the 0, or you can think of it as being just there isn't any x, and so they don't matter. All right? All we end up with y is equal to 2. Y does not really depend upon the x in this case. All right? So if that's the case, how would I graph this? Well, I don't really need to go to the x is equal to 100, the x-axis. X is equal to 100. I just need to go to the y equals 2. So remember, the y-axis is the one that's going up and down, vertical. So where does y equal 2? Well, y equals 2 is right here. And then I would say, no matter what I plug in for this x, it's going to be 2. So I chose 100 and a negative 100, but I also chose a 3. So at 3, y is 2. At 5, y is 2. At 6, y is 2. At negative 6, y is 2. At negative 3, y is 2. At negative 3.3333, y is 2. Okay? So no matter where I go on the x-axis, it's always going to be on the 2 for the y-axis, which makes it pretty simple. So the graph is just simply a straight line drawn right at y is equal to 2. All right? So hopefully that makes sense to you. So if you have an equation such as this, y equals 2, you're going to end up with a horizontal line. The only difference is on where that horizontal line is going to be. So if I have y is equal to 4, well, that's simple. It's just going to be a graph that is going to be horizontal on the y is equal to 4. All we did was move it up. Okay? Excellent. Well, now let's change gears, and let's say that instead of y equals 2, what if we have x is equal to 2? Okay, so we still have an equation. Now, again, we could try to force this into an equation of 2 variables by pretending that there is a y to the 0 after the 2, let's say. But another way to look at it is just that the y doesn't exist really, so the y values don't matter. So again, if you were to draw your chart and you have x's and y's that you're plugging in for this, it doesn't matter what you plug in for the y in this case because there isn't any y. So you're kind of forcing y to be the independent variable here. So if y is 100, well, there's nothing to plug that into unless you think of it as y to the 0, which is going to be 100 to the 0, which is going to be a 1, times a 2, which is still 2. So no matter what happens with the y, x is always going to be 2. The difference here is x is always 2. In this one, y was always 2. So if x is always 2, then I just go to my 2 on the x-axis, which is right here, and I say, okay, well, no matter what the value is for y, x is always going to be 2. So when the y is a 1, let's say, x is a 2. When y is a 3, x is a 2. When y is a 5, x is a 2. When y is a negative 2, x is a 2. When a y is a negative 5, x is a 2. So you can see pretty clearly here that what we're getting is not a horizontal line. We're getting a vertical line in this case. So if we set x equal to just a number, we end up with a vertical line, straight up and down. okay, centered on whatever x is equal to. So if x is equal to, let's say x is equal to a -4, well, that would just mean that we have a line centered on -4 going straight up forever in both directions. Okay? Should probably put these here too. Excellent. So that is how that is set up, just like that. Now, those are some examples. I think those are, well, you know what? Let's do one more here that you might see, and I don't want this one to confuse you. What if we have, oh, what color should we go with here? What if we have y is equal to x? That one kind of throws people off sometimes. It really shouldn't. It's really easy, but let's just look at it just so you don't get confused if you see it in your seat work. Y is equal to x. So we have our x, we have our y, and we're going to select some values here. So let's select x is equal to 0. Well, if x is equal to 0, what's y equal to? 0, right? If x is equal to 1, then y is equal to 1. If x is equal to a -1, y is equal to a -1. If x is equal to a 2, y is equal to a 2. So the points just kind of double up on themselves. So we have a 0, 0 point, which is right in the middle, the origin, as they call it, of the graph. And then we have a 1, 1. So 1, 1 puts us here. And then we have a -1, -1, which is going to be here. And then we have a +2, +2, which is going to be here. And we can see that we are developing this line that is actually shooting up. Let's see here, something like this, kind of. See if I can. No, maybe it won't let me spin that. There we go. So we got our spin there. That's a little bit better. So we have this line that's going up at the angle like this. It's a straight line. Oh, my goodness. For infinity in both directions. So that would be the graph for the y equals x. All right. So hopefully this all makes sense to you. It is pretty straightforward. It's just a matter of plugging in some values and then playing dot to dot on the graph. All right. So go ahead and we'll stop here, I guess, and start working on the seat work for these. And we will continue these in future classes as well.